In this lesson, we're going to learn about gravitational forces. And by the end of the lesson, you should be able to learn more about gravitational fields and weight. So what are gravitational fields? Now, all masses have a gravitational force of attraction between themselves and any adjacent mass. The larger a mass is, the stronger the gravitational force of attraction that they will exert on smaller masses. And the region around these large masses is usually called the gravitational field of that large mass. Small masses that are very close to the surface of a large mass is said to have a force called the weight, and this force will be talked about later on. Let's look at the relationship between the force and the mass. Consider two masses m1 and m2. m1 is going to experience a force due to m2 and we'll call this F2. And m2 is going to experience a force due to m1, we'll call this F1. Remember, when we talked about forces, we say that they occur in pairs and they occur in an opposite direction to each other. Notice these two forces are paired and they point in opposite directions. The force experienced is directly proportional to the product of the masses. That means F is directly proportional to m1 multiplied by m2. And it is inversely proportional to the square of the distance between their centers, represented by the symbol d over here. That means F is directly proportional to 1 upon d squared. So what is the force due to the gravitational field called? We've already said that any mass that is very close to the surface of a large mass with a gravitational field will experience a force, and this force is usually called the weight of that smaller body. But we've never stated a direction for it. Let's consider the Earth with its gravitational field acting towards the center of the Earth. Notice that each one of the forces are perpendicular to the surface at a point, and they point towards the center of the Earth. If a person is standing at this point on the Earth, what they would notice is a flat surface, and the gravitational field lines would seem to point vertically downwards. Therefore, that means that the weight itself acts in a downward direction and it is experienced by all masses close enough to the surface of the Earth so that it will experience this gravitational field. The weight of a body can therefore be found by this formula here. Notice the weight, represented by the symbol capital W, measured in newtons, capital N, is equal to the mass of the body, represented by the symbol m, measured in kilograms, multiplied by the gravitational field strength of whatever gravitational field that it is in, represented by the symbol G, and measured in newtons per kilogram. Notice it is the amount of force per unit mass, and we'll talk more about this later on. The gravitational field strength is represented by the symbol G, and the gravitational field strength is defined as the force experienced by a 1 kg mass, as shown by the units newtons per kilogram. Notice this means force per unit of mass, and a unit of mass is 1 kilogram. The value of G for the Earth is considered to be a constant, but this is not really true. The Earth itself is not made uniformly, so the value does not remain constant. For example, a place that has an iron pocket below it has a value of G that is different from a place that has a gas pocket below it. Now, the value you should be using, since we consider it as a constant, is the value of 10. At this level, this is the value that is most accepted. At higher levels, you are expected, however, to use the value of 9.81 newtons per kilogram. Another name for the gravitational field strength is the acceleration due to gravity. It has this other name because any body inside of the Earth that experiences motion in a vertical direction will tend to experience either a speed up or a slow down. Hence the word acceleration due to gravity. Another unit for the gravitational field strength is the meter per square second. And as you can see, it is the unit of acceleration that we had earlier. Now, on a side note, the gravitational field strength of the moon is 1/6 that of the Earth. So that means if it is that we are using the value of 10 for the gravitational field strength of the Earth, it means divided by 6, and this will be the value for the gravitational field strength of the moon. So if you have any questions, you can reference these two textbooks, or you can simply send me a message and I will answer your question. Thank you very much.